While thinking about the key performance indicators and metrics used to drive your business, I want you to think about three scenarios: vegetation management, disaster recovery, and DER integration. What's the same about them with respect to things like SAIDI and SAFI? The answer is that by the time you recognize that one of these programs has caused a drop in your SAIDI or SAFI, it's too late to do anything about it. My name is Jake Freevold from Fulcrum, and today's webinar is about from reactive to predictive, data-driven asset management for the modern grid. And we're going to cover a number of topics today. We'll begin talking about the measurement and metrics necessary in discussing SAIDI and SAFI. We'll consider the effects of low-quality data, how to prioritize getting that data quality up, smart technology, which we look to for data very often, but also how smart humans fit into that scenario. We'll talk about the data architecture for all of this, and we'll consider how all of this relates to AI. Let's start by going back to those measurements and metrics that, like SAIDI and SAFI, that we want to discuss. And I'm going to begin with Peter Drucker, who said famously, "You get what you measure." It's a great pithy statement about how we use metrics and key performance indicators. And I should note that key performance indicators and metrics are technically different. A key performance indicator is a measure of how close you are to your goal. A metric is just a count of something. So you're supposed to do 100 inspections. You did 75 of them. The metric is 75. The key performance indicator is 3/4 or 75 out of 100. I'll probably end up using them interchangeably a lot here, but technically there is a difference, and you should keep that in mind when you're talking to the right people. Anyway, when we consider SAIDI and SAFI and any number of other key performance indicators we might be looking at, we're looking at the impact that our various tasks have taken on have had on our business. The outcomes that we've gotten might include outages and recoveries from those outages. Those go into SAFI and SAIDI. We might have things like equipment failures, which cause product delays. Those are also outcomes of a process and the impact they had on our business. The important thing to note here is this is all stuff that happened in the past. You're looking through a rear view mirror when you talk about these metrics. So they're called lagging metrics, or lagging indicators if you prefer. What's really important is to understand that if these are lagging metrics, they are only showing us what has previously happened. We need to find a way to drive the measurements that we're making upstream so that we can catch things as they're happening before they become a problem, before they actually have an impact on SAFI and SAIDI. So we might look at our inputs, such as the time, material, and funding that we put into our activities. The activities themselves might include inspections and training. They would include actual activities, the bread and butter of what we do, like spraying spraying pesticide or trimming trees. And the outputs would include, for example, the number of inspections that were passed, the amount of people who took the training, the average quantity of herbicide that we're spraying. These are all leading metrics. Leading metrics are the way that we detect what's happening early on so that we can drive those downstream results. We can actually think of SAFI and SAIDI as the verification of the fact that we're doing the right things when we're focused on the time, funding, materials, the activities that we're engaged in, and so on. Those key performance indicators are actually just verification that we were doing the right things up front. Now, there's another pair of people, Kaplan and Norton, who built a whole methodology about this, and they call it the balanced scorecard. Balanced metrics, and I'm not going to go into the scorecard itself, it's a whole methodology and it's more complicated than we need to talk about here. But the important thing about the balance in the balanced scorecard is that it recognizes that lagging metrics are the goal, and the leading metrics are the things that we measure in order to understand that we're finding ways to achieve our goals. And I think it's really important to remember not only that you're going to be using these metrics to keep focused on what really matters, right? You're going to measure things in leading metrics that are going to help you achieve goals in lagging metrics. And if you don't do that, then you're not going to be focused on the right things. So you got to stay focused on those, the correct issues there. But it's also important to make sure that you're not doing things like punishing people for reporting what's going on. There's a natural human tendency when somebody is complaining a lot, telling you this is why that delay happened, that's why that delay happened. There's a natural tendency to say, well, that guy's kind of a whiner. Well, that guy kind of isn't getting the job done. Maybe he's not capable of doing it. And to be fair, maybe they are. But that's not the presumption that you should have, because if you punish people for reporting the causes of delay in this case, or reporting safety incidents or safety near misses, if you punish them for doing that, people will learn. and they will no longer report near misses, and they will no longer report those causes of delay. And that means that you will not have the information about the delays, about the safety, about all of the other aspects of your business that you really need to fix. So take the metrics. Don't be a complete servant to the metric. You've got to be able to understand the balance between the metrics and how to get the information you need without punishing the people who are trying to tell you what's actually going on in your business. So if we take that idea and return back to these three topics, we can consider what we are doing, the actions that we're taking, the inputs that we have, the outcomes that we're getting from them, and start to really consider these in the context of the data needed to capture metrics. So, vegetation management, we're having some kind of inspection that's taking place to see where the vegetation management is necessary. We're sending work crews out. Notice that that's not a metric per se. We're just talking about work crews being sent out. That's part of the process. But there's data we can get from that. Equipment and material management, they need to spray a certain amount of herbicide. They need to wield a certain number of chainsaws on the crew. All of that information, or all of that use of materials, has data associated with it as well. Pre-work conditions, we need to see what it looked like originally for a couple reasons. First, to know that the inspection ahead of time actually told us what we needed it to know. Maybe we used drone footage to see where we thought we would need to do some work, and it turned out not to be the case. That pre-work information is really important to make sure that we are going to be effective going forward. And we need the post-work conditions, not just for QA, although we need it for that for sure, but also to see what it took to get the results that we need. So there's data in all of that as well. Now that's the only one of these that I'm going to read from soup to nuts, but disaster recovery has similar kinds of requirements. DER integration has similar kinds of requirements. I'm going to note that DER integration frequently happens through contractors, and so there may be some slightly different way of collecting the information you need, or different people you talk to about the data, but getting that information is still going to be really important. With all that in mind, let's talk about the data that they can use in the field and the data that they can acquire in the field. First, we'll consider assets. Now, I've got 4 categories here. You can have whatever number of categories you like. This is not a methodology. This is just a way of grouping things so that we can talk about them intelligently. Assets, of course, have individual types. You might have one that's a 55 kilowatt transformer. You might have a location. The location can have different aspects to it. Is it an address, or is it a latitude, longitude, that sort of thing? The individual asset has a condition, and it has a history. The condition is what it is now. The history is what it has been before, what maintenance has been done on it, and so forth. So there's a ton of information that we need to have about the assets, and while we're out there in the field, we're going to collect information that adds to that history, adds to the current condition. Even the location can change, right? If a pole gets hit by a car and a replacement is put in place, that might move some distance from where it originally was. So depending on the precision you have and so on, these things can all change in one way or another. Materials are similar. We've got different types of materials. We've got the quantities that we need to use them. I've already mentioned vegetation management a couple of times, for example, the amount of herbicide you might use, that sort of thing, the frequencies with which they're applied. All of those aspects of materials both need to be understood by people so they know what to expect. They know how much herbicide to expect and therefore how much to have on their truck. And if we collect that information about how much was applied, we'll know what we can expect in the future as we send more teams out to do that kind of work. Actions include things like installation and maintenance. I'm going to emphasize at this moment that we're not just talking about inspections, right? When you go out for an inspection, you're doing something that is data collection inherently. But many actions are not data collection. If I'm installing a piece of equipment, that's not an inspection. That's not data collection itself. That is putting a piece of gear into a spot and, tightening bolts and attaching wires. But there's stuff that we need to know about the action that we'll take when we're installing. We need to know what type of wire we're going to need, and we're going to need to know what kinds of actions we're going to need to take. Not only the individual steps to install and maintain equipment, not only the individual steps we're going to need to trim trees or spray vegetation, but also things like safety checks. If we really want to create a culture of safety, then the safety check should be an inherent part of the installation process. So actions are much more than just data collection, but we can get data from the actions that we take. And I'll talk a little bit more about that in the future here. And then finally, there are issues. What kinds of issues are frequently seen when we go out to do the work that we're doing? If we know the delays and we know their causes, then we can tell people, oh, that road only has four-wheel drive access, so you need to make sure you've got a four-wheel drive truck when you go out there. They can recognize scope creep, and they can try to prevent scope creep by saying, hey, by the way, the customer that you're working with might ask you if you can do X, Y, and Z. That typically adds an extra half hour onto the job. We can't do that unless they pay more, or whatever the situation might be. QA problems that cause delays can be really important. And we need a way to understand what those QA problems are before we go out in the field, so we have everything we need to do to avoid them. And while we're out there in the field, it would be great if we could collect information that could be used for QA after we're all done. So all of these different categories have information, have data that we need to provide to people about them, and we need to get from people in the field so we understand what's going to happen next. If we consider the effects of not having good process data, then we go into what I like to call multi-order effects. The first order effect, of course, is going to be that you're much less efficient at what you do, which means that it's going to take you an hour and a half instead of an hour, which means that planning is going to suffer because you were planned to be there for an hour and they weren't able to be as efficient as they could be because you were an hour and a half. They might have to shift jobs around, etc. When planning suffers, the squeaky wheel frequently gets the grease. So something is broken, that's what gets fixed. Things get rearranged to accommodate the failure more than the planning that should have gone into or originally did go into the task at hand. Another thing that we see is revisits and rework because you didn't have the right stuff on the truck, so you've got to go back out again. Or you thought you had all the process information you needed, but there was a part of the process that you skipped, so now you've got to go back out and do some revisiting or do some rework there as well. And then finally, customer satisfaction decreases. If you're working directly with customers, obviously, you're going to see that right away, but you'll see that over time regardless. But in some cases, it can be a first-order effect. In some cases, it's a second-order effect as well. And which brings me to second order effects. One of them is that you're spending too much time and too much money on operational activities, which means you're increasing your operational expenditures, which means you're spending more of your budget on OpEx than on capital expenditures. And that's really important because every dollar that goes out of the company on operational expenditures is basically gone from the company in that moment. But capital expenditures are investments. Literally, they are the kind of thing that when you spend $1, you're going to get long-term benefits, both in terms of amortization and so on, and your taxes, and in terms of the effects that the upgrade to your capital the upgrade that your capital expenditures brought. So, if you spend more money and time on OpEx, that means that you're letting money go out the window when it should be being spent as much as possible on capital expenditures, which would give much higher benefits over the long run. That puts you in a bit of a quandary, right? Because you need the money, which means your rates are higher than they need to be, but you've also got lower profitability or lower return to your members. So the second order effect of higher rates and lower profitability is a double whammy from a financial perspective. And of course, now we're starting to see the longer term effects of things like safety and SAIDI, where those are becoming worse over time, and you are therefore not meeting your objectives. You're not able to show your regulators that you're doing what you need to do. You're struggling to keep ahead. And that's really the third order effect, is that because you're spending so much time keeping the tires on the moving car, you're not able to actually change those tires to be what they need to be. So you've lost your ability to improve. These are all effects of not having good process data. So let's turn that on its head and say, how do we get better results? Safety, SAIDI, the second order and third order effects we were talking about. How do we get better results than we did before? And the answer is, interestingly, to focus on those first order effects. We think it's strategic to focus on safety and SAIDI. That's true. It is strategic to focus on them, but we focus on them as goals. We focus on the first order effects to see what we need to do to achieve those goals. That means we're going to prioritize fixing the data related to leading metrics. We need to fix the QA data up front. We need to fix the amount of the example I've been using is the amount of spray herbicide that you've been using to execute your jobs, the amount that you have of that you have on the truck. We need to begin to focus more on fixing those metrics first so that we can steer to the better metrics downstream. One of the first order effects that's most important, of course, is better operations planning, which comes from greater efficiency. When you know what you're trying to accomplish, you're able to plan to accomplish it much more effectively. And that helps you shift from the reactive maintenance side of the business to being able to do more preventive maintenance. Another major issue is the efficiency per truck roll, because when you roll out a truck, it's one of the most expensive things you can do. Then ensuring that you're as effective as possible is really critical. That means that remote supervision, for example, is a way to allow people out in the field to take data about what they've done. That data is not limited to numbers and characters. It also could be photos or videos. And being able to push that back to supervisors so those supervisors can QA while they are still at the work site, so that you're not letting them leave until you've done the basic QA to understand that everything's been done correctly. That reduces your truck rolls, and it makes sure that you've got the maximum efficiency from each truck roll that does go out. And in fact, with respect to better operations planning, if you have enough data with respect to the preventive maintenance, then you can start moving to predictive maintenance. Let me explain what I mean. Reactive maintenance happens when you don't have any data and things just pop up and they just happen. Preventive maintenance means you're starting to collect data. You've got some data about what is being maintained and in what way, and you're able to decide, okay, well, I don't know for sure when this particular one is going to go, but I know that I should probably do some maintenance on it now to prevent it from going. Predictive maintenance is when you have a lot of data. You've done preventive maintenance for some time and you've got a lot more data, and you're now able to look at things and say, I want this specific one to be done next because based on mean time between failures and the kind of signal that I'm getting out of it and a sensor that I've got on it and now that I've got all this information, I'm able to say that specific one has higher priority over this other one that would be sooner on the preventive maintenance schedule because I think that one's more likely to go. And then similarly, when you're focused on the efficiency per truck roll, once you have developed enough data, you might be able to get more tasks done per trip. You send people out on the trip, and if you know that they can get a certain amount of work done in a certain amount of time with a certain amount of equipment, then you can say, you know what, if I just added a little bit more equipment to the truck, then I would be able to route them to this other site that's very close by and get an additional task done. Being able to get that kind of multitask efficiency out of a single truck is really, really important. Now, I've been talking a lot about data and how we get data, and one of the things that always comes up when I talk about data is smart technology. And it makes sense that we're thinking about smart technology because we're getting all the benefits that you see here, better data and so on. But we should also be thinking about the smart people who are out there in the field, because we frequently will think about, getting smart meters and stuff like that, but we're still giving this guy a clipboard. And that's problematic because if we have the ability to give this guy the ability to give us better data and real-time data and all the benefits that you see here, we also have the ability to be more process-focused. And if we're process-focused, then we understand not just one individual piece of data. The smart meter may be telling you 60 times a minute what's going on, but it's only telling you one piece of information, not the entire process of installing and taking care of the various maintenance jobs you've got to do. This person is focused on the entire job. And because of that, he's actually in some ways a lot smarter than the smart technology that's out there. So what we'd like to do then is focus on turning the field worker actions into data that we can get from the field worker instead. Inspections are always a process of collecting data. By definition, that's what they are. But when we're doing installations and maintenance, there's other data that we can get from it. Pre and post work conditions, we can get other information from that. Quality assurance checks as well. For example, yes, the data that comes from an inspection is the situational data, what's actually the condition of this piece of equipment right now. But those other things too, the installation and maintenance tells you about the equipment and the asset location for that asset that you're installing. It gives you that information at the same time. You get future visit expectations. You might, when you see quality assurance data, you might see scheduling and training requirements coming out of that quality assurance data, which helps you, again, push efforts up front in your process to get those leading metrics taken care of, in this case, better training, so that you can improve the lagging metrics once you've done the training that's necessary to get people to be better at what they're supposed to do. So we turn field worker actions into data in order to get better data from the field in a process-oriented way. Now, getting that data is complicated. And I'm not talking about complicated because the technology is complicated, although that's true, it can be somewhat complicated. We'll get to that in a minute as well. But I don't want to understate the amount of effort it takes from a pure business perspective. Process standardization is one of the things that we have certainly seen as being both critically important and sometimes extremely difficult to handle. Now, the field knows its process better than anybody else. So at Fulcrum, we focus on making sure that the field can update its process standards as much as humanly possible. We want them to be the owners of the process. But we find that when we are implementing different kinds of applications, different kinds of processes, one of the issues we face is people not knowing what the process is in the business. I was talking to a customer service, customer success rep here at Fulcrum recently about one of his customers. And he said that one of the divisions, they were trying to bring 4 divisions together to get a single standardized process. There were people in Long Island, New York, and upstate New York, and I forget where the other places were. They were trying to bring them together. It seemed like a pretty straightforward process. But they all thought of it differently. Their teams engaged differently. They had different clients, external clients on, for the process that they were engaged in. And they didn't understand each other even to some extent. And the IT person looked at it and said, this seems pretty simple. Why are we having any issues? And the answer is strictly because the business people themselves were struggling to bring their processes together. That's something that can't be understated. You need to think about how these processes are going to be standardized, how you're going to communicate, how you're going to work together to make sure that that happens. We actually, see a significant benefit when there are managed services along with any Fulcrum sale that we engage in, not because, you need all this extra work done, but because we understand the guidance necessary to bring people together to make sure that you've got the right process in place. The other thing that's important here, it's also not technology related. By the way, what I'm just talked about, that would happen whether you bought Fulcrum or whether you're using Survey123 from Esri or whether you're using some other technology. It doesn't matter. Clipboards, same thing. You'd still have the same problem. So this is not a technology issue. The second thing to understand is data standardization, which is something that should be undertaken in conjunction with both IT and with business stakeholders. IT, because they understand this problem. They may not understand the field very well, but they understand the data standardization problem. They know what it takes to do integration work across systems. They've seen that. They know what it takes to get data flowing from one system into a data lake or a data warehouse or data mart or whatever their particular model is. They know what it is to get data and try to standardize it and bring it together. They also know what it's like to work with business stakeholders who are trying to say this is important and that's not, right? The enterprise asset management team knows what's important to them. The GIS team knows what's important to them. I'll get to this more in a minute too. The field team understands that there are things that are uniquely important to the field team that those other people don't care about. So figure, a walkabout, a video walkabout before you do a piece of maintenance on a pad-mounted transformer. That is probably not important to the asset management person. It's certainly not enough to store video in their application, which they're probably paying, a data charge for. It's not important to the GIS team. If you ask the person who maintains, Survey123 forms to insert a video just because you feel like it, they are not going to like that because they don't want it to go into ArcGIS, and they shouldn't want it. That's unique to the field. So working with stakeholders, business stakeholders to understand what's important to them, and IT to understand how to standardize the data formats and so on to make sure that we're aligned closely is really, really helpful. Now, maybe you're getting off the ground. Again, Fulcrum is designed to make sure that the field teams are able to do whatever they want to, however they want to. That's all good. And then when you're getting off the ground, starting is better than doing nothing. But especially as you gain success, especially as you start to build out, data standardization, just like process standardization, is going to become increasingly important. The third thing I'll mention is interface management, and I've alluded to this already. I don't mean interface like, graphical user interface on your phone. I mean interface between you and systems, and you would do this in conjunction with IT because they're the ones who are managing a lot of the integration processes between systems inside your organization. That's if you are an employee and you're serving, a utility. Or in conjunction with customers, if you're trying to interface between customers and give them the data they need. So if you're a service provider and they say, oh, well, we need it in this form, or we need it, to go into Esri, what does that look like? We need it to go into Maximo, what does that look like? And so on and so forth. Interfaces between systems become critically important. So the data that you're dealing with, I just want to reemphasize, is a business problem that people need to get engaged in, not just a technology problem, although IT should be involved to make sure that they understand what's going on because they can help guide you through these issues. Let's talk about interface management, though. The title here is wrong. I apologize. It's not that. That's anyway. The interface management comes about because the people that I've been talking about, your enterprise asset management team, your GIS team, your enterprise resource planning team, they all have a business domain of their own and an application that helps them manage the processes and data within that business domain. So in the field, we say, okay, well, because I need to get information for EAM, I need it to get for Maximo, I'm going to use Maximo Mobile to get that data. But then they also say, some of that data needs to go into ArcGIS. So I'm also going to use ArcGIS to do that as well. I'm going to use Field Maps or Survey123 to do that. And oh, by the way, I'm going to use some of the safety steps involved are here. I'm going to use Velocity EHS's mobile app, whatever it may be. So what people in the field start to face is they've got multiple user interfaces they need to deal with, or they've got a spreadsheet, or worse yet, a clipboard that they take notes on, and then that gets later transcribed and uploaded by someone else or through some spit and baling wire process into the various applications that they need to put it into. But it actually gets worse than that because that's only step one. If in a multi-step process, you're going to have that happen over and over and over again. And by the way, I've said put that information into. There's also a certain amount of getting information from these systems that you need to do as well. You're chasing a lot of things here. You're chasing the fact that each one of these things might have separate licensing. The requirements for the mobile device that they're running on might be different. There's a lot of problems here. And one of the problems, and I'm going to come back to this later, is that the field doesn't recognize the fact that it also has a business domain and it also deserves a place to manage its data and processes. So all of these other business sections do, and the field doesn't. We'll return to that in a couple of minutes. So we've been talking about metrics that improve with better data, better process data, better early data, right? Those leading metrics. Let's talk about what else improves with process data. And to do that, it's a little interesting. I'm going to use a video, which is not something I commonly do. I'm going to use a video that shows you something that I couldn't describe to you properly if I tried. So I'm going to bring up 2.5 minutes worth of a video. The speaker is going to be the AI in Fulcrum. So sometimes she'll talk to you, and sometimes she'll talk to the field worker. You'll see how all of that works as we go forward. 2.5 minutes. Let's see what it looks like.
Take a look with me at what the future holds when our field worker puts on his smart glasses with camera and microphone and gets started with his AI-guided experience in Fulcrum. We've arrived at pole 1734. Please look at the top so I can scan for issues.
Sounds good.
I've already guided him to the right power pole. Now I'll capture some information so he doesn't have to, still under his control, of course. No visible defects in insulators or other features.
I agree, log it.
I can help him remember what he needs to do.
Guy wire tension is good.
Okay, what about the guy wire covers?
Oh, right. Covers look good as well.
Got it. Ready for the pole itself?
Let's do it.
The pole tag should read 1734. It appears to be defective. Do you agree?
I agree. It's missing the 3.
Noted. Also, some cracking, but no major defects. Do you agree?
I agree. Log it. Hammer sound test.
There's more to all this than data capture. I help capture the right data with minimal effort, seeing what he sees, guiding him through the process.
Hammer sound is good. Probing below the soil line.
Just like I can help field workers with their jobs, I can keep the office informed of relevant field information.
Northern quadrant might need a second look. What's the SOP for reinspection below the soil line?
The manual says that potential defects should be reinspected and remediated within 30 days. Should I alert the office that pole 1734 should be reinspected using a shovel, along with a pole tag replacement?
Yeah, do it.
The pole's inspected, the status is logged, nothing was missed. This is the future of Fulcrum. We're creating an AI-guided experience for every field worker. Last inspection of the day, pole 1735, 50 meters northward up this street.
Metal or wood?
Metal.
Sounds good. I'm going to put my belt in the truck and walk over.
You're due for a water break too. It's 87 degrees.
Good call.
So if we consider everything we've been talking about with respect to data, to me the most critical question is, where's the data and process information that the AI can use and analyze to give the field worker the information that he needed in this scenario? If we consider the sanity checks, right? So she asked specifically, what about the guy wire covers? Because he had missed it. There was part of the process that he had missed, which means the AI has to have a view into the entire process to be able to know to ask that question. So where does that live? And in that complex siloed environment that we talked about before, it lives a little bit of everywhere. It's in the EAP and the EAM. It's in each of those mobile devices. It might be on paper. It might be in the head of the field worker because the process isn't fully documented anywhere in particular. And that's a major issue. And in fact, it's actually somewhat worse than that, because if you consider the applications that we've already talked about here, and there may be many others that we're dealing with, there's also an Access database that Jenny's got on her computer, and there's a spreadsheet that Tommy keeps, and there's all of this information out there that gets used in little ways to keep track of the processes that we engage in. Where does AI go? In fact, which AI are you going to use? Because I'm pretty sure that the EAM vendor is going to use their flavor of AI, and the GIS vendor is going to use their flavor of AI, and all of those other people are going to use their flavors of AI. And in the long run, you're going to have quite a number of different places to go in order to get any work done. Not only do you not have a single place for the AI to go to get processed data, you don't even have a single AI trying to interact with you to get that processed data. So having one place, staking a claim on having one place to manage your data and your processes is a critically important part, not only of achieving those metrics, but also of taking advantage of these future capabilities. And that has implications for our architecture. We need to get rid of this mess because it has too many points, too many touch points, too many data points, not enough process control. And we need to move to a single field platform that's going to have that. All we're doing is saying that just like your asset management team needs an application, a platform to manage its data and processes, the field needs a single platform to manage its data and processes. This is not a completely new idea. There's a resource from IDC that talks about this specific requirement. Lynn Schneider, who has been with IDC for some time now, and she works in the data as a service area and also focuses on location and geospatial intelligence, recognizes the need for the specific kind of location-enabled field process and data collection platform. And that's a document well worth reading, which you can get from the Fulcrum website. Now, Fulcrum is approaching the AI vision that I just laid out there in different ways. That, by the way, was a vision. That is not available today. There are different things that are available today, like, for example, audio fast fill, being able to speak People think about voice to text, but that's not enough for the field, right? You need voice to data, voice to yes, no buttons and radio buttons, voice to comment boxes, yes, but where I have multiple comment boxes and one discussion can check all those boxes and put things in the comments. That is available now and is already being used by a number of companies. Data Insights is coming soon. That's being able to capture information by talking to not capture information, but to get information out of Fulcrum by talking to it, by giving it plain language commands and saying, show me the following things. You'll be able to get information from Insights. The real-time QA and anomaly detection, what I call the sanity checks in that video, those are coming soon on the roadmap, getting that interactive guided field workflow, and eventually reaching that fully hands-free AI and AR-enabled field process. This is the set of phases that we are going through to achieve that vision. And it all rests on the ability to have a single place for your field data and process information. That's what Fulcrum is. We are a field process management platform. And we do this because we know that field teams struggle with inefficient tools that cause more frustration than help. That frustration is very real to us and very real to our customers. And in order to get rid of that frustration, we provide a field-first platform. Everything that we do is looked through the lens of what the field needs first. And that platform is designed specifically to boost productivity and streamline your operations. And if we can do that, then we are sure to help you not only achieve better asset management in general, but to see how we can use data-driven asset management to really achieve those major objectives that you have and hit the metrics that you've got, hit the key performance indicators you've got that are showing you how well you're doing your job. That's all I've got right now. Unfortunately, I'm not able to do questions. This is actually a re-record of something that I did live, so we don't have the questions available right now. We had technical glitches before. I would like you, if you are interested, to visit us at DTech 2026. That's coming up very shortly, and Geo Week, which is only a couple of weeks after that. And if you do come out and visit us, you can look for a demo for everything I've talked about today. You can discuss architecture, you can discuss data, you can discuss your processes. We'd love to have that conversation and set up the right kind of demonstration for you to show you how Fulcrum can be of value to you. I know you could have done other things for the past hour. Thank you very much for spending that time with me, and I hope to interact with you soon.